Alright, hello everyone. Today we're going to be talking about the differences between acceleration, displacement, and velocity. Alright, so let's start with displacement. So let's say we have a car and it's traveling from this point, so point A, to point B. Alright, so, and between them it is 10 kilometers. Okay, so be careful with displacement and distance. They're actually different things. So displacement is the shortest possible distance between 2 points. So for A and B, this arrow that I have drawn is actually the shortest distance. It's a straight line, right? Displacement is always measured in a straight line. But if we're talking about distance could be from, it could have gone out this way and then back through here and then all the way to B like that. That might be the distance. But the displacement is the shortest possible length between point A and point B. And let's say that that's 10 kilometers. So displacement, which we use S for displacement, is 10 kilometers, but it is usually measured in meters. So we convert that to 10,000 meters. Okay? Alright, that is displacement. Now let's have a look at velocity. Let's have a look at this car here. It's not the best drawing in the world, but it doesn't matter. We have a car, and we're using the same example. It's traveling between point A and point B. Now if we look at its, at the way it's moving at this specific point along its journey. So it's going from A to B, and at this point, it might be moving at, let's go 100 meters per second. And this number here, the 100 meters per second, that would be its instantaneous velocity, okay? Because that's how it's moving at that specific point, okay? Now, it is not speed, okay? Speed is different. Velocity looks at displacement over time. Speed looks at distance over time. So when we're talking about velocity, it is just talking about displacement over time. And it's measured in meters per second. Okay? So that's its instantaneous. We'll talk about average velocity as well. Alright, so average velocity is a little bit different. So average velocity, it's still measured in meters per second, okay? But we're looking at the average velocity that it traveled from A to B. So before we're looking at the velocity at a specific point, but this time we take into account every velocity that it had between A and B. So the average velocity, okay? So it might be, what was the other one? Let's go 105 meters per second between point A and point B. That would represent its average velocity across that time. Alright? Now, looking at acceleration, okay? Now, acceleration is the rate of change in velocity. So, how fast is its velocity increasing or decreasing? For example, if we have a car, and if it's traveling at the same speed, then it won't have any acceleration until it stops. That would be deceleration. But if we look at between point A and point B, if it moves at a constant, let's look at its velocity here. Let's say its instantaneous velocity is 100 meters per second. Alright, now that is a very fast car. But let's say that is its instantaneous velocity. If it stays at that velocity throughout the whole journey between point A and point B, then there won't be any acceleration until it stops. But if it goes from 100 meters per second, and let's say that it now pushes the pedal down a little bit, and then it speeds up to 120 meters per second, alright? So if we got 120 meters per second, then that means that there had to be a change in velocity at some point. At some point it started to speed up. So that acceleration is the change in velocity. So it's the change in velocity over time. All right. Now, I didn't mention this before, or I said it, but I didn't do the equation. Now, velocity is a change in displacement over time. Okay. So that's something else to remember. Velocity and acceleration here. But if we focus on acceleration, acceleration can be positive and negative, so can velocity. But if it's a negative acceleration, that means that the car's actually started hitting the brakes and it started slowing down. So it might be going down to 50. And then eventually if it arrived at B, it would slow down to 0. But that would be a negative deceleration. Okay. Now acceleration is measured in meters per second. So that's the units that you use, but -2 at the front. Okay.